say.
You're on, Jack.
I'm Jack Mogner. I'm trying to give these guys some idea of what it is to solder, although they jumped the gun on me and been doing pretty good without me. So I quit. No, we were asked to do the class on soldering. A lot of soldering around the model railroad here. Biggest thing is probably soldering feeders to the rails. Something like this, although this is a demonstration. It's not nearly what we'd use, but the concepts are the same. Basically, we've taken a soldering iron. One end's hot, one end's not. First step is to learn which is which. There's a number of different types of solder. It varies mostly in size. The problem with this, once you get it melted into a joint, you end up with too much of it. It's very difficult to control. It's much more effective to use a smaller gauge solder. That way there, when you start melting it, you can feed it in until you have enough, and you very seldom will end up with too much doing it that way. It's very easy to end up with too much with the larger stuff. Most of the solder we have here is tin lead. Newer stuff is lead-free. To be honest with you, I've never used it myself. I don't know much about it. My stocks of tin lead solder will last me until I meet my maker. So, I'm not about to change over. Soldering tools. Typical wire cutters, wire strippers, pliers, flux for the soldering. A lot of solders have flux built into it. You'll usually see the label as rosin core flux or rosin flux, which tells you that the soldering flux is built into it. Flux is merely a chemical agent which, when heated, activates and cleans the joint area to be soldered. One of the things that's really necessary when you're making a solder joint is that the two places being joined are clean and bright. If you have oxidation or something like that, you will quite likely have a very ineffective solder joint. So, the flux, this one here is called soldering paste, but it's basically the same thing. You can dip a wire in it, for instance, prior to tinning it. Tinning is nothing more than heating up the end of the wire and coating it with solder. What that does is basically helps you when you go to make a joint. If you tin both surfaces prior to trying to join the wires, or join the wire to, in this case, the rail, you will usually find that you have a better joint with less heat and less consequent damage to the ties, which are often plastic nowadays, or the wire, which in many cases will have a vinyl insulation, which can easily melt back if there's too much heat too long. So, soldering irons. That's the tool you use. It's nothing more than something that gets hot. The question is, there's a number of different types. Some of them are temperature controlled, as is this one here. And that one too, right? Yeah. Others are just a plain soldering iron of probably, this one here is 25 watts, I think. 45 watts. 40 to 45 watts will do a sufficient job on rail. If you're doing, if you're trying to put in a Dakota or something like that, that's probably marginally high. Fine electronic work, wiring inside the locomotives. If you go above 25 watts, you're probably treading dangerously because it gets too hot on the internals. On the temperature adjustable irons, it's always best to adjust them so that you can do what you have to do with the minimum amount of heat. In other words, you don't want to turn out full blast because then you'll end up with too much heat and you'll start doing damage as you try to make your joints. One of the good things about these is that when you're not soldering for a little while, you can always dial them back down low, keep the iron warm but not hot, because when the iron's hot, you tend to oxidize on the hot end of the iron, which means you have to do more cleaning. If you cut it back down to a relatively low heat, you come back up to a soldering temperature pretty quickly. A lot better than turning it off and trying to restart it. But anyway, what's next? All right, we covered soldering irons.